before we go on solving the molecular mass, there are a few things that I would like you to remember. So these are the following terms. If you see the terms such as molecular weight, ground formula mass or GFM, formula mass or FM, and molecular mass, they all pertains to molar mass, right? So other textbook may be using different terms, so just in case, don't get confused. Okay, so all of these terminologies that I checked technically pertains to molar mass. Same goes with the unit. The unit is expressed as grams per mole, and then sometimes it is expressed like this or like this. Now let us examine the periodic table again, because here in the periodic table we can see the atomic mass or the molar mass of a given element. So when we speak of molar mass of the element, okay, we just simply refer to the atomic weight. Like for example, for boron, okay, this is boron, the atomic mass is 10.81 grams per mole. The molar mass is also 10.81. For carbon, okay, this is carbon, that is 12.011. That's the atomic weight. That also pertains to the atomic mass. Alright, so let us find the molar mass of chlorine. Now, if it is alone, or a single atom of chlorine will have this following molar mass, 35.45 grams per mole. But you will see here it has a subscript. So to find the molar mass of chlorine, all we have to do is multiply the atomic mass by 2. So let's write it down. So the element given is chlorine. So the atomic mass is, or the atomic weight is 35.45 times the number of chlorine, which is 2, and that will give us 70.9 grams per mole. So let's find the molar mass for methane. By inspecting or by looking at our periodic table, we can see that the atomic mass for carbon is 12.011 and for hydrogen is 1.008. So for methane, the element present again are carbon and hydrogen. So let's write them down. Carbon, hydrogen. The number of carbon is 1, although it is not indicated here. There's no number 1 here. It is understood that it is 1. The atomic weight is 12.011 times 1. That will give us 12.011. Right? Now for hydrogen, the atomic mass is 1.008. Now look at the subscript. So we just multiply the atomic number by the number of subscript. So that is 4. That's 1.008 multiplied by 4. That will give us 4.032. And then all we have to do is take the sum. Okay? Take the sum of these two. That will give us 16.043 grams per mole. So this is the molar mass of methane. For sulfuric acid, the elements present are hydrogen. There are 2 of hydrogen present, sulfur, 1 sulfur, and 4 oxygen atom. And listed here are the atomic weight given at the bottom of the elements in the sulfuric acid: the hydrogen, sulfur, and oxygen. So let's write them down. Hydrogen, sulfur, and oxygen. Okay, let's have hydrogen first. The atomic mass or the atomic weight of hydrogen is 1.008 multiplied by the subscript, which is 2. This will give us 2.016. For sulfur, since there is no subscript, it is understood as 1. So the molar mass, the atomic weight is 32.06 times 1, that gives us 32.06. For oxygen, there are 4, right? So 15.999 times 4, that gives us 63.996. Now, we just add all these three together to get the molar mass of the sulfuric acid, or 1 mole of sulfuric acid. So that will give us 98.072 grams per mole. Now, for aluminum sulfate, the elements present are the following: aluminum, sulfur, and oxygen. And by looking at the periodic table, the atomic weights of these elements are given here at the bottom. Okay, so let's write them down. We have aluminum, sulfur, and oxygen. Right, so let's start with aluminum. The atomic weight of aluminum is 26.982 times the subscript, or by its subscript, which is 2, meaning there are 2 aluminum element or atoms here, and that will give us 53.96. And then sulfur, there's no subscript, that's why it is understood as 1, but you have to take a look at the 3 here. Okay, sulfur is inside the parenthesis, so that means you have to multiply the number here, or the subscript here, to the one that is outside the parenthesis. So it becomes 1 times 3 equals 3. So the sulfur is 32.06 multiplied by, again, 1 times 3, that gives you 3. So that gives us, the product is 96.18. Now for oxygen, okay, let me write down first the atomic weight. So that's 15.99, right? Now how do we know by what number should we multiply the atomic weight of oxygen? We just simply multiply the subscript that is inside the parenthesis with the subscript outside. Just like the one on what we did with the sulfur atom. So, diba, isa to, multiply natin siya sa 3. So, understood na merong 1 to, or 1 yung value niya, times 3, that's why we have 96.18. For oxygen, it should be 4 times 3, that's 12. And that will give us 191.98, okay? And that will give us 342.13 grams per mole. So this is the molar mass of 1 mole of aluminum sulfate. Now let's try magnesium sulfate pentahydrate. The dot here just simply tells us that this magnesium sulfate is surrounded by 5 moles of water. So the element presents are, we have magnesium, sulfur, oxygen, hydrogen, and another oxygen. So by visiting again the periodic table, you can see the atomic weight here at the bottom. Okay, and let's write them down. We have magnesium, sulfur, and oxygen. Let's take this first before we get this, okay, or before we solve this pentahydrate. So magnesium has atomic weight of 24.305, and the number of magnesium present in magnesium sulfate is 1. So we have 24.305. Okay, and then the sulfur is also 1. So that's 32.06 multiplied by 1. So it is also 32.06 here. While oxygen, there are 4, so that will be 15.99 times 4, and that will give us 66.996. Okay, now the sum of these three, okay, let's add them together. that is 120.361 grams per mole. But we're not yet done because we have to solve for this one too. Okay, now this time it has a coefficient. Okay, the coefficient is 5. That is the number before, right, the compound. This tells us that there are 5 moles of water. Right? Now, let's write down the elements given. We have hydrogen and oxygen. So let's write down first the atomic weight of hydrogen. That is 1.008. Now, there are 5 moles, okay, of water. So that means we have to multiply 5 and 2 here at the bottom. So that's 5 times 2. That will be 10. Right? And that will give us 10.08. Right? Again, where did we get the 10.08? We multiply 5 and 2. Right? This is 5 times the subscript 2. Right? That's why we're able to get 10. Okay? So we will do the same process with oxygen. So the atomic mass or the atomic weight for oxygen is 15.999. So that's 15.999 multiplied by, so we have 5 here times 1. Since there's no subscript, it's like before I told you, if there's no subscript, it is understood as it is 1. So 5 times 1 is 5. Okay, so that will give us 79.995. And then when we add this together, we will have 0.75, right? When we add these two together. Okay, now we have to find that the sum or the total of these two numbers. Okay, so when we add these two, we will get 210.436 grams per mole.